So today we will learn about the dilations and reflections of the function. And we will do it on the example of the function f of x equal root x. And first, let's look what happens with the dilation. And there are two types of dilation. We can have dilation from x-axis, and we can have dilation from y. Dilation from y-axis. So dilation from x, when we change f of x, we change to a some number times f of x. When we multiply y value by some number. So that's why dilation from x, the graph is stretched along y-axis or compressed, depends if the value of a is less than 1. So how we do mapping notation? So we will have that x dash does not change. We don't change x. But we change y. The new y dash will be equal a times y. We multiply y by some number. Again, as we're doing working backwards, we find x equals x dash, and we find what will be the all coordinating terms of the new will be y dash divided by a. And for example, we have this is a graph of root x, y x, and let's say we have point 4, 2, and we change root x to the graph of 2 times root x. So that means we multiply every y value by 2. How we will match the mapping notation? We have that y dash equal 2y. So y equal y dash divided by 2. We sub it in. Here we have y on 2 equal root x, and y equal 2 root x. So that's following the mapping notation. So as we multiply every value of y, we multiply by 2. So what was 4, 2 becomes now 4, 4. And the graph is dilated by factor 2 from x-axis. Make sense? It's pretty straightforward. Now, let's see what happens when we have dilation from y. That means we change f of x, we change to f of a times x. We multiply a, we multiply x by some number. Let's use mapping notation. We have x dash equals ax, y dash equals y. We're not changing y, we're changing x. So x will be equal x dash divided by a. So let's apply it, for example, to the graph. We change root x to root of 2x. We multiply x by 2. So we have y dash will stay y dash equals y, and we have that x equal x dash equal 2x. So x equal x dash sorry, let's do it in this way. X dash equal 2x, and what will be x now? X dash divided by 2. We sub it in, we get x on 2. We get x by 2. So this graph, y equals x on 2, is stretched twice from y-axis. When we have x on 2, if you look here, we're saying that every new x is twice bigger than it was for same y, which results in the root of x on 2 when we walk backwards. So when we have y equal root x on 2, the graph becomes twice wider. It's multiplied by 2 this way. It's stretched twice from y-axis. So when we have dilation from y by factor 2, in the formula it will be x divided by 2. Because we will need now twice bigger x to get same y. So we will have then 8 for same y. To get the same y, we will need twice bigger x. We will have now 8, 2 from 4, 2 becomes to 8 on 2, and the graph is stretched this way twice. I can see that some people doesn't make sense. So again, we say y doesn't change it. We say dilation from y by factor 2. So we multiply, to get new x, we multiply every old value of x by 2. That is dilation by factor 2. To get what it will be in the formula, we write new x equal double old x. We rearrange, we find that old x equals new x divided by 2. And we sub it back into the formula y equal root x. We get what? Y equal root x on 2. So when graph is twice stretched away from x, from y-axis, for same y, we will have now, we'll need to have twice bigger x. We will have x on 2. Not 2x, but x on 2. Because to get the same y, 2, we will need twice bigger x because we divided it by 2. Make sense? Okay, that dilations from x, dilation from y. So if you want graph to become twice clothed to y-axis, what will be the formula? We want graph be twice clothed to y-axis. Will be y equal square root of
ax.
And we're saying twice, so 2, a equals to root 2x. If we have y equal root of 2 times x, we will have, so this is, we have old x equal 2x dash. So new x is twice smaller than the old x. So graph will go twice closer to the y-axis, so we will have point 2, 2, and that will be the graph. So if we have root of 2x, graph is like compressed to what, twice compressed to what the y-axis stretched. If we have x on 2, we have graph stretched in this direction. Now let's have a look into the reflections. Reflections are more simple than dilations. So reflection in x-axis, reflection in x-axis. In x-axis, so we have f of x changing to negative f of x. So we have y change to opposite. Y change to opposite. We have x stay the same, x dash equals x, but new y dash equals negative y. From here, we get y equal negative y dash, and root x becomes y equal negative in front of the root. In this way, we will have that every y value change to opposite. So we had, so that is root x, and this will be negative root x. With this point now becomes, we have same value of x, but y becomes negative 2. When we have reflection in x-axis, it's like in the mirror reflects in the x-axis. Make sense? And now reflection in y. In y, we will have f of x change to f of negative x. We change now x to opposite. So we have y stay the same, y dash, new x equal negative of x, so x equal negative x dash. And the function becomes y equal negative, becomes the root of negative x. We change x to opposite. And we have graph now reflected in y-axis. So keeping the same values of y, but this becomes negative 4, 2. So this is a reflection in the y-axis. Let's consider the next example. So your textbook, exercise 7b. Exercise 7b. Question. Question 2. And let's consider the transformations that will happen with a, let's say, truncus. Y equals 1 on x squared. So we have original function y equal 1 on x squared. And write down the equation of the image obtained when the graph of each of the functions below transformed by dilation of factor 1/2 from the y-axis. Dilation by factor 1/2 from the y-axis. So we have, if it as a dilation from y does not change. It's the same y. But new x, we say dilation by factor 1/2, so we have 1/2 times x. New x is 1/2 times x. That means dilation from y by factor 1/2. Let's rearrange it. We get x equal 2x dash. So we're substituting this into the original equation, and we'll get y equal 1 divided by 2x squared. 2x squared. Which can be simplified to 1 divided by 4x squared. So what will happen with the graph? What will happen with the graph of the truncus? It shrinks twice. It's coming twice closer to y-axis. Make sense? How we obtain the formula. going through the mapping process. Of course, with the experience doing equation, you will be able, at least in the simple equation, you will be able to just write the equation straight away. But generally saying, if you go through the mapping process, you will be getting it right all the time. Now another, let's say, dilation of factor 2/3 from the x-axis. Dilation from the x-axis means we have now y dash equals 2/3 y. Y dash equal 2/3 y. Dilation from x we change in y by factor 2/3. So new y is old y multiplied by the factor 2/3. When x stay the same, x dash equals x. So let's rearrange this one. We get y equal 3 on 2 times y dash. Let's substitute it into the original equation. We will have 3 on 2y. We just drop in dash. We substituting, but we not write in dash. 3 on 2 y equals 1 on x squared. And usually we write in function with the y by itself. So that becomes y equal 2/3 times 1 on x squared, or y equal 2 on 3x squared. So what happens with the graph of the truncus? What happens with the graph of the truncus? It shrinks like 2/3. It shrinks vertically, comes closer to x by the factor 2/3. So can you tell me if I will write the next equation? Let's say original was y equal root x, and now we change it to y equal negative root of negative 3x, of negative 3x. What transformations happens here? Yes?
It's reflected on the x and the y.
Reflection in y, reflection in x, and what else? Dilated from
1/3 y.
From y by?
1 negative
By? No, first of all, negative.
1/3.
This negative already taken into account that that is reflected.
1/3.
1/3 by the factor 1/3. So that will be dilation from y by factor 1/3. One more example. Let's do it with a hyperbola. If we have originally 1 on x, y equals 1 on x, and now we change it to y equal, hyperbola probably not the best example. Let's do it with the parabola. So we have y equal negative negative x squared divided by 4. What transformations happen? Yes?
It's dilation from the y in a factor of 4. And it flips around.
Dilation from y by factor 1/4. Dilation by shrinks 4 times means dilation factor 1/4. And what else happened? Reflection in x-axis. How we can find those transformations, identify them? So let's first move 4 to other side. So we have 4y equals negative x squared. And then we move minus there, we have negative 4y equal x squared. With the mapping, using mapping notation. This is, remember that this is the mu in terms of the mu. So we have that x dash equals x. Comparing, what we have originally y equal x squared. That's where we started from. Does anything changes with x here? No. Now y dash, we have that y, we obtain y equal negative 4y dash. Then what y dash equal? What y dash equal? Negative y on 4. What transformation is that? We multiplied y by 1/4, so it shrinks vertically 4 times, and we reflected, we change y to opposite. So that using mapping notation, when we using mapping notation, first we need to rearrange it to have everything that changing y on the left, everything changing x on the right. And we can see we have x squared, we have x squared. Nothing changed. Yeah? So x dash equals x, no changes. But instead of y, what we have now? Negative 4y. So now we need to walk backwards. We know that we substituted here. Remember how we do the process? We identify x dash, y dash. Then we rearrange, we find an x and y, and we substitute them into the original formula. That means that we substituted instead of y negative 4y dash. From here, you find what was actually y dash. Now when we have this formula, it's clear y was reflection in x-axis, y changed to opposite, and it's multiplied by 1/4. Questions? Yes?
I don't get, like, I thought I was supposed to leave it as not y dash, like just leave it in terms of y.
Yes, but when we're trying to withdraw, when we derive the new equation, so let's do this process again, but from x squared to get to the negative x squared on 4. So we do that, we do reflection, so we have xy. Now, when we do reflection in x-axis, does x changes? No. What happens with the y? Change to negative y. Now, when we now multiply, we do dilation from y by 1/4. We still don't change x, but we multiply y by 1/4, get negative y on 4. This we follow if we do now like equation in reverse. So we're not given the final equation. We have original equation y equal x squared, and we have that it's reflected in y-axis, reflected in x-axis, and dilated from x by factor 1/4. And we do never do, when you will be identifying those things, never do few transformations at a time. Do it step by step. First step, this is reflection in the x-axis. We change y to the opposite, to negative y. The next, we do dilation from x by factor 1/4. So we multiplied what we already have here, we multiplied by 1/4, that's what we got. So those are our x dash and y dash. So we have x dash equals x, y dash equal negative y on 4. Let's substitute them into the original equation y equal x squared. So we will have negative, so let's rearrange it first. X equal x dash, and y, the old coordinates equal negative 4 y dash. And now we substitute in the old coordinates, like we were doing all the time, into the original equation. We have negative 4y dash equal x dash
After this,
squared.
yeah.
Now we just drop dash and leave y by itself. We get y equal negative x squared divided by 4. Make sense? Make sense? Did it clarify your question? Yeah. Any other questions? Okay. Like, subscribe, and donate to help fight terrorist countries and organizations, Russia, Iran, etc. Support Ukraine and Israel.